after we apply the power rule, this is what we get. And then from here, we can go ahead and simplify this. This 1 e to the power of x is just e to the power of x. So we have 25 times this right here, xe. And and then from there, we just distribute the 25 to each expression, which leads us to this, and this is our answer. This is the derivative of this whole function.
So we're given a function of negative 2.3 x minus 1 to the second plus 8, and that's the function for millennials. And so the constant in this function would be negative 2.3, and then we would drop the plus 8. So with the x minus 2 to the squared, that is two functions that we can break up into u and y. So u would be x minus 2 and y would be u to the squared. And then to find the derivative of u, we have to plug it into the equation, and that would bring us to 1. And then for y, it would be 2x minus 2. So after that, we would put it back into another equation, and it'll be negative 2.3 times 2x minus 2. And then we'll distribute the 2 to the x and the negative 2. And so we get the negative 2.3 x minus 4. Then we distribute again to get the equation of negative 4.6x plus 1.
So, in order to find the derivative of the equation 12 times the sine of 0.33x times the cosine of 0.33x, we must first simplify these, the sine of 0.33x and the cosine of 0.33x together, because we know the cosine of x times the sine of x is equal to the sine of 2x over 2. So if we apply that to this equation, we'd have in the parentheses the sine of 2 times 0.33x, which is where we get the 0.66 from. And this 12 is brought down alongside here to multiply by the equation that we found. But since there's a 12 times the 2 in the denominator, it would reduce to 6. And that's how we get the 6 times sine of 0.66x. And from there, we can actually go ahead and find the derivative. So using the constant multiple rule, we can just bring the 6 down, and then to find the derivative of this part, we find the derivative of the inside phrase first, which is 0.66x, and the derivative of that would be 0.66, and multiply it by the derivative of the whole thing, which would be cosine of the inside phrase, so cosine of 0.66x. From here we can simplify further by multiplying out 6 and 0.66 to get 3.96 times the cosine of 0.66x.
Alright, so right here we have the graph for our original function, which is 25 times e to the negative x. And then right here we have the derivative of our function, which is right here, shown right here. And basically right here, right here we basically prove that this is the derivative of this function, because if you can see here, the values are pretty much the exact same. And then, well, if we go back to what this graph actually means, we can see these values represent the time in months, and then this one represents the amount of products sold, in millions. So baby boomers, after 2 months, they've bought 8 million products. So yeah.
X minus 2 squared plus 8, and the derivative of that is negative 4.6 x minus 2. So we find the slope of them, and we have these, which is y over x, and we graphed both the original and derivative, and saw that the original was decreasing, and the derivative is kind of connecting with it as its slopes are matching. And so when we look at the slope and the derivative, they're close together, in which they are accurately correct and would give a good answer.
So for our proofs, we use both graphing and spreadsheets. On the spreadsheet, we made a very small step size, and we found the actual slope and the change in y over the change in x, and compared it to our calculated derivative, what the change would be. We compared the numbers to see that they were pretty close, and then when we graphed it, we saw that for our actual data, we could see that it matched up pretty well with what our derivative would be to show how much it would change or decrease by a certain time. And the scaling would be how many millions of products you'd be able to buy in a certain number of months.